Okay, let's look at Sage Math and some matrix operations. So here I've put in four different matrices, A, B, C, and D. A here has 2 rows, 3 columns. B, 2 by 2. C, 2 by 2. And D is 3 by 3, 3 rows, 3 columns. And I've already put in a couple of things. So here I show n rows, so I'm just going to have this Sage cell here print out how many rows A has and how many columns A has this way. I also did, I made a new matrix by taking B plus C and calling that F, and then I show that F, and then B times C. Now I could have done like G equals B times C, but this is just to show that I can just immediately print out the result. And if I hit evaluate, so our first show was rows of A by columns, so 2 by 3. Here I did the addition of the B and C, so I had 7 plus 2. 7 plus 2 is 9, and so forth, so I got that. Here's the multiplication of B and C, and again it's a 2 by 2 matrix. And now, scalar multiplication. So let me just go back here. F was B plus C. Now let me multiply that by 5, so 5 times that. So F, remember, had the 9, 11, so I should see here 45 and then 55 for the first row. Evaluate, yeah, 45, 55, 65, 30. So I can do that. I could have done it back here, so 5 times, now I need parentheses if I'm going to do the sum first, and I'll get rid of that, and so evaluate. And so the Sage syntax for doing this is pretty straightforward. If I make my matrices and then want to add them together, I just add them together. If I want to multiply them, I just multiply with an asterisk, and there we go. Now notice here, to print out the 2, 3, I actually forced a comma in there with double quotes. So I said double quote, comma, double quote, because if I don't, it doesn't bother with the comma. So if I evaluate now, it looks like I got the answer 23. And so that's a problem. I could have just printed out, I'll do a Control X to get that out of there. I could have just done the rows and then come down here and just done the columns like that. And then I wouldn't have needed to figure out how to do that comma. So there's my 2 and my 3. But to just put a comma in quotes to force that comma in between them and do that. There we go. Okay, so this all worked. Now, but let's look at like A times B. Now A is 2 by 3, 3 columns. D is 3 by 3, so it has 3 rows. And so here I'm going to show A times D, and then I want to show D times A. And if I do that, so there's A times D, 2 by 3, because A had 2 rows, D had 3 columns, so I got a 2 by 3. But notice here, D times A, I get all this stuff, and if I go to the bottom, it says unsupported operand parents, full matrix space of 3 by 3 dense matrices over ring, and 2 by 3 dense matrix. So it's getting into a lot of technical stuff, but one, I see there was an error, and then the other is I can kind of finally get, it was a 3 by 3 times a 2 by 3. I can't do that, right? So that didn't work, and so it gave me an error because that's not defined, which again shows that multiplication is not commutative, generally speaking. It might even not be defined to switch the directions. Now, B and C, we can switch those. So here's B times C, and then C times B. So I can do that because they're both 2 by 2, so that's going to work. And evaluate. But of course I see I get 2 different answers. So we did scalar multiplication. Now addition, right, here's A is 2 by 3, B is 2 by 2, so I would expect that if I try to do A plus B, it shouldn't work. And sure enough, you see I get an error. And it's putting an arrow right here at the show A plus B. It's saying it can't work, and so it just stops, and I never get to see my multiplication there. So, it can't do something that's not defined. So, so we have that. Now we can multiply those both ways. Now the interesting thing here is, let me go in and modify D and make it 3 by 2. Now the thing is here that now if I take A times D, well, that should work because A has 3 columns and D has 3 rows, so that should work. But if I turn around and do it the other way, D times A, this should now work because D has 2 columns, A has 2 rows, and so we should be able to define that matrix multiplication. But again, we see how the commutativity is not there at all. We don't even get the same size matrices, right? So A had 2 rows, D had 2 columns, so A times D, we got 2 by 2. But then when we switch it around, well, D had 3 rows, A had 3 columns, and so we got a 3 by 3 in that case. Okay, and I think those are, addition. We could have done subtraction here. Let's do, well, we can't do A minus D. If I try to do A minus D, they're different sizes, so I'll get an error. Sure enough, I did. So let's try B minus C, since they are the same size. And there we go. So we could do B minus C, and so subtraction works just fine. We did scalar multiplication, and let's see. Let's try one other thing. Let's put an equal in there. Evaluate. Let's see, and see it didn't do anything. But now let's try a double equal. Let me see what happens. And notice it says false, so I can check whether 2 matrices have the same values. So if I did change this to an A, does A equal A? Notice I get a true. So I can also do things like check whether a couple matrices are equal. All right, and again, there's this quick reference guide for linear algebra. There I had clicked it and it came up, and so here, for instance, under pieces of matrices, we see the n rows and n columns. Here are some vector operations. Here's matrix multiplication, and it talks about doing this. You can even raise a matrix to a power, so that would be to multiply it by itself over and over. Now again, some things won't be defined. In order to do a matrix power, I have to have a square matrix. So for instance, b is squared, it's 2 by 2. And so if I do b squared and hit evaluate, it's thinking quite a while here. Well, what I'll do is I'm going to do a Control C, copy this whole thing, and reload the Sage page, and Control V to paste it back in, because notice when I reloaded it, nothing was there. There we go. And so there I got b squared, and so that was b times b. But now if I try to do a squared, the problem is a times a is not defined. And so you see it says we can't do this. Self must be a square matrix, right? So in order to do that, we had to have a square matrix. Okay, and I think that's pretty good for Sage and the matrix operations, and so we'll end it there.